So we're going to take a look at today this thing that we've been learning, I don't know, for a couple weeks now. I think it was since the first day of the semester. The fundamental theorem of calculus. And we're going to apply it. This is the main goal right here. I think for the last several weeks, we've only used our calculators to get the answer. For one part, we've used the Riemann sums to get an estimate of what the answer is. And then in some cases, we've chopped up the areas into like triangles and circles and trapezoids to get the answer. Okay? But not until this moment here are we going to actually find the answer to the problems actually by hand. So let's just recall what the fundamental theorem of calculus is. It says that the integral from a to b, which is my starting and my ending point of the interval, start and end. And if we're integrating over some function, which I'm calling f prime of x, okay, that's equal to then the change in the position of the f function on the same interval. We've called this answer, we've called it the net change in the function. We've also called it the displacement of the function. Okay, it's not total distance unless it's all unless the area is all positive or all negative. That's the only time it would be total distance. Okay, so this is what we're going to do today. So let's snag one, and then we're going to compute it, and we're going to see what we get for an answer. Let's just do one which, it seems like it's harmless. The integral from 1 to 2 of x squared minus 3 dx. We're going to do this by hand. And it's a requirement on the AP exam. You have to be able to do this. But then we're going to test our answers using the calculator and see if it's right. Okay, so the way that we do this is we say, what kind of integral is this again? What is that called? It's a definite integral. Okay, when it has these, so what's the answer to a definite integral? It's a number. Okay. So we're going to get a number for an answer. But the way we do it, we said was, well, wait a second. If I take away the 1 and the 2, that means what we have to integrate. And that's what we've been doing the last couple of days. So what's the integral of x squared minus 3x? X cubed divided by 3 minus 3x squared over 2. You got this. Then plus constant, right? Okay. Now, what we do here is we do kind of a combination of a definite integral and an indefinite integral. The first thing is we have to write you have to find the antiderivative of this, and that's what this is here. Okay. This is f of x, if this was f prime of x. Then, this is the new notation here. I'm going to put a big bracket over here, and I'm going to put a 1 and a 2. Okay? This is new notation that you got to know. What it means is we're going to take So if you start with a definite integral, we're going to find the answer. The first step is to find the antiderivative of whatever function you're given. And then you put the brackets here. This means we're going to evaluate this integral from 1 to 2. Okay, so what this looks like is we're going to take 2 and we're going to plug this in first. So I'm going to put it in parentheses so that we don't get all messy. 2 cubed over 3 minus 3 times 2 squared over 2 plus c. Does everybody see this is f of b? Little side note. This is f prime of x. This is f of x. This is f of b. You see the big picture? See how it is? Okay, bless you. Now we're going to find f of a. F of a means we're going to plug a 1 in for each of the x's. So it's 1 cubed divided by 3 minus 3 times 1 squared divided by 2 plus c. And what you should observe is this is f of a. I'll even put here, this is a and this is b. This is how it's all related. And what we're doing is f of b minus f of a. It's really actually simple when you stop and think about it. Take this function, you integrate it, and then you plug in the b, then you plug in the a, and you subtract them. That's all it is. All right, let's get the answer here. 2 cubed over 3, that's 8/3. What is this one? 4, 2, 6 plus c minus 1/3 minus 3/2 plus c. And what do I got? I guess I'm just going to write it out. 8/3 minus 6 plus c. Then I'm going to distribute the negative here. So it's minus 1/3 minus 3/2 minus c. Plus 3/2. Thank you. You guys are going to all go to college next year. You're going to be in a math class of some kind. It's going to be 200 people in the lecture hall. And the professor at some moment is going to make a mistake early on. No one's going to say anything. And he's going to carry out the whole thing on like 3 boards. And then it'll all be wrong. Just saying. I want you to be that person. Doesn't it help when you fix me? Doesn't this help? You catch my errors, that's good. I'm not offended. Okay, 8/3 minus 1/3, 7/3. Negative 6 plus 1.5. Yeah, negative 4.5, if you don't mind. 6 is the same as 12/2, right? So that's negative 12/2 plus 3, so that's negative 9/2. And what about our c? Plus c minus c, that turns out to 0. Okay. All right, so what's 7/3 minus 9/2? Let's do a little math here. Common denominator of 6. So that's 14. That's what, 18? 27. I was never good with numbers, so. I just love saying that. Okay, and then what do we got here? 14 minus 27. Negative 13 over 6, which is what? Negative 2. and 1/6. Okay? All right. So that apparently is the answer to this original problem. Okay? Seemed kind of harmless, but kind of got a weird answer. Okay? All right, pull out your calculator, get the real answer. Go get the estimate from the calculator. All right, so everybody knows how to do it this way, correct? Just, you can go straight to the answer. X squared minus 3x dx, and bam, right? And we know that 1 divided by 6 is 1.6 repeating, so we've got the correct answer. Yeah, now it's in the picture. Okay, now just because I like sometimes to just drill this in, so it's never ending. Type in the function, do the graphical view. Okay, make sure you can do the graphical view. Get me the answer to that integral using the graphical view. Okay, I want you to be fluent in all of the methods to get the answer and see the relationship between all of them. Okay? A graphing calculator is required on the AP exam, okay? Because half the test is calculator based. Okay, cool. Well, let's do another one. So what if we say this? It's the integral, let's say from 1 to 4 of 3 times the square root of x. We follow the exact same format. You guys want to jump in and do this one by yourself? I can sense that already. You're all over it. Okay, you do it and then I'll do it and we'll compare. Get 14? Okay. Now, you should be able to do this one without a calculator. Okay? So just to double check, 3 divided by 3 halves, okay, 3 divided by 3 halves is the same as 3 multiplied by 2/3. It's the same as multiplying by the reciprocal. Okay? So just see that. 3 divided by 3 halves is the same as 3 multiplied by 2/3. When you divide by a fraction, you're multiplying by the reciprocal. There's other algebra ways to get there, but it's 3 times 2/3, which is 2. That's where this 2 came from. Okay? That's the first thing I want to point out. Second thing is 4 to the 3 halves. Okay? You can do that in your head because you do the power and the root, and it doesn't matter the order. Okay? So let's do the root first. Square root of 4 is 2. 2 to the 3rd is 8. 8 times 2, 16. Okay. You could do it the other way. 4 to the 3rd, 4 times 4 times 4 is 64. Then the square root of 64 is 8 times 2 is 16. The order of those two doesn't matter. Okay. Anybody notice a pattern on one particular thing with the first two, just in general? C cancels out. See, C cancels out every single time. Is there ever going to be a time where it doesn't cancel out? Okay, so it'll always be there. So actually from now on, you don't have to write the C when you're doing the fundamental theorem. Okay? And it's totally accepted that you don't have to write it because it always disappears because we're subtracting it from itself. Okay. All right. Did you do the third one yet? Okay. Do the third one. Harry, what would that be?
So if you're doing an indefinite integral, do you still have to write the C and then
Yes. Because there it's still existing. This one's actually a lot easier than it looks, doesn't it? What is the antiderivative of the secant squared? Just simply the tangent. Because we know the derivative of the tangent is secant squared. Yes, we do. Now you'll notice here, I'm not writing the C anymore. I won't write the C anymore when we compute these because we don't have to. You got that one covered? Okay. of course, we know our unit circles with tangents. Answer is 1. Okay. So the area under the curve from 0 to pi over 4 of the secant squared of theta is equal to 1. Okay, if we graph the whole thing, we'd see that. Now, just to recall a couple of things, in case you don't remember it, now it's kind of hard to go from here to here, but do you remember, if you don't remember what the derivative of the tangent is, do you remember what you can do? Quotient rule. Remember, if you're saying this, it's the same as the sine of x over the cosine of x. And if you do the quotient rule on this, bottom times root of the top, so on, you'll end up with secant squared. Okay? And then, if you don't remember your tangents, where they are, just think, okay, what does it mean? Where did that come from? Okay? The tangent of theta, remember, came from that tangent line. Okay, remember that? It was the distance. And at pi over 4, we go up to here. And the question is, how long is that line? Well, it turns out that this is a 45, 45, 90, right? With a radius of 1. So that tells you that the tangent of pi over 4 is 1. So it's all there. Okay? You just have to know the fundamental things, and then you can build off of that. Harry?
Will the other aspect of tangent question and the non-calculated?
Yeah. Yeah. You actually got to know all 6 of the trig functions for any of the standard unit circle points. And it's only in radians. Yes? The inverse tangent? Yeah, you'll have to know those. It's a tough one, though. You gotta just they're reversed because they're inverse trigonometric functions. But you'll be asked to do. I would have to say there's probably at least a dozen questions on the exam where you have to do a unit circle. And they're buried within problems. It's not just find me the cosine of something. Yeah. All right. Make sure you see this. Page 291, which is this section, 4.4, is due Thursday. I'm going to be talking about it for the next several days then.
When's the unit 4 test?
Before we leave for spring break.